Hello and welcome to another one of D's ADD videos. Today we're going to look at an example of trig substitution. I'm going to explain the concept looking at this problem here, the integral of dx over the square root of 4x squared plus 9. So you should go through the list of possible algebraic manipulations, which there are none here. You can't do long division, separate numerators, or anything like that. You can't do substitution, you can't do by parts, there's no partial fractions, you can't factor that denominator. So you're kind of left with no options, so you think trig sub. And you see that there's a plus sign here, so that plus sign indicates that it should be a u equals a tan theta or a box equals number tan theta substitution. So if you go off to the side, box squared equals 4x squared, square root both sides, and you get the box is 2x. And then the number squared is 9, so the number is 3. Oops. So we get, when we substitute, 2x equals 3 tan theta. So that means everywhere I see a 2x, I can plug in 3 tan theta. Well, I don't really see a 2x. So I need to rewrite the problem to where I can visualize what's going on easily. And we know that 4x squared is nothing more than 2x all squared. So then we have a 9 here, and then we have the ability to plug in, and we get the square root of 3 tan theta. Here, I'll write that in red because that's the part I'm plugging in, just so you can visualize it better. So that's the new part, 3 tan theta, and it's being plugged into a problem for the 2x. And then there's this dx up here. Well, I need to have dx in terms of theta. So let me go off to the side and figure that out. So if I divide both sides by 2, I get x equals 3 halves tan theta. So then dx will equal 3 halves secant squared theta d theta. Alright, so at that point, now that I have that, what I can do is I can plug that in up here for the dx to get a new problem of, again, I'll write the new part in red. So 3 halves secant squared theta d theta over, and I'm going to square that to the 9 tan squared theta plus 9. Alright. So then I can factor out the 9 out of the denominator, pull this out in front. So if I were to do that, I would have a 3 halves out front, secant squared theta d theta over 9 square root tan squared plus 1. Factor out that square root of 9 becomes a 3. And that tan squared plus 1, if you remember, equals secant squared. So what will happen is that 3 in the denominator will cancel with this 3 in the numerator. And you'll be left with 1 half integral of secant squared theta d theta over secant theta. Seems like my dogs are having fun downstairs. Sorry about the extra noise. Cancel the secant squared. There's 2 up top, 1 on the bottom. And your new problem becomes a much more reasonable integral of that there. And if you remember, the integral of secant is the natural log of secant theta plus tan theta. It's easier to remember this integral than to try to do it with u sub. It's a much more complex integral. Just remember that one. So now I got to go back to my expression. If you guys remember earlier, I set up the expression of 2x. Is it 2x over 3 or is it x? Let's see. Yeah, it was 2x over 3 equals tan theta. You guys remember that earlier? So what I can do is set up a triangle from that, a right triangle, where there's my theta, and tangent is opposite over adjacent. If I did it correctly, the Pythagorean theorem, verify that on your own, just square this one plus this one squared gives you that. Now I have a relationship for the right triangle that allows me to find either secant or tangent or cosine or sine of whatever this theta is. So my final answer then would be 1/2 ln of secant, which secant is hypotenuse over adjacent, right? Reciprocal of cosine, so it would be that, plus tangent, if you remember, that's this thing, so we don't have to use a triangle for that, and then plus c, and that's your answer. If you wanted to, you could put these over a common denominator, make it over 1/3, but that's good enough. Alright, I hope that has clarified any confusions that you might have over trig sub. Make sure you check out the example for secant and the one for sine as well. Thank you and have a nice day.